So what are the traits of a healthy questioning attitude culture? Procedure writers and job planners avoid complacency and continuously challenge existing conditions and activities to identify discrepancies that might result in an error or an inappropriate action. Additionally, they are watchful. So we make sure that we're watching continuously for assumptions, anomalies, values, conditions, and activities that adversely affect safety, quality, and human performance. Now, some of the attributes that fall into the questioning attitude deals with: one, we need to understand that complex technologies can fail in unpredictable ways. Two, you got to challenge the unknown. We got to stop when faced with certain uncertain conditions, evaluate and manage risk before proceeding. Three, when it appears that something is incorrect, we need to challenge assumptions while also offering opposing views. Number four, we got to avoid complacency. We got to recognize and plan for the possibility of mistakes, latent problems, and inherent risks, even while expecting successful outcomes, right? So the first thing I'm going to do is, and then some of you that have followed me may have seen this little short snippet of the Deepwater Horizon movie that was out a number of years ago. Back on April 20th, 2010, we had probably the largest industrial or environmental industrial accident in United States history, resulted in 11 fatalities and 17 injured. Now, in this video, what I want you to be able to do is, this is a situation where they were doing some testing, right before this explosion occurred. Now, what they were going to do is that originally, after they, well, I'll show this slide here, is that I'll show you this link. If you look at this link from the CSB, this link on YouTube goes into it's only about 10, 11 minutes long, goes into really good detail about how this accident occurred and the failures that they occurred. But in the video that we're going to show, in this video, what they were trying to do is doing some testing. And what you'll find out is the testing was not going to according to what they thought they were going to expect. So then they decided to test it in other ways. But watch the communications between the people here and think of it in relation to the questioning attitude. So when you look at the questioning attitude that was in the room, right, can you see some of the lack of the questioning attitude in these statements from the CSB? Now, these excerpts on the screen are taken right from the CSB report, cut and pasted for it, right? And so, as you can see here, the Chemical Safety Board makes a statement and says, hey, look, complex systems almost always fail in complex ways. Such was this blowout at this well. While multiple safety barriers had been intended, all were penetrated by complex, multiple failures caused in total by an unrecognized, key thing there, unrecognized technical issues, procedural weaknesses, and human errors. So here, if you watch that video closely, they were talking about how, well, we have this problem and we have this hypothesis and we think that there's a pocket of pressure there and then we could have a problem with any of the 1,000 moving parts. And did they stop? No. They kept right on moving. Well, we'll just test it another way, knowingly that something was off with this drill pipe, right? Something was off, but did they have that questioning attitude that caused them to stop, get the right people involved? No, it did not happen, right? Now, additionally, they got into the procedure side of things as they did the Chemical Safety Board. And even here, an expert hired by BP comes out and says, hey, look, an expert hired and said, hey, you know, when they run this negative test, the rig crew does not need to be told how to run a negative test. Great questioning attitude there. Chemical Safety Board comes back and says, wait a minute. This should be a routine, or BP, right? The BP expert says, this should be a routine operation that fits within their training. Chemical Safety Board comes back and says, well, no, wait a minute. This sentiment does not address the fact that procedures are more than a set of instructions. They're built for competent people, motivated people, the plan, coordinate, verify, and to assure performance will achieve the intended results. End to end down here, there was finger pointing back and forth about who should have wrote the procedure and whose responsibility was. And then I put a blue box around. What was left? The crew. The crew was left to try to put something together to get the work done. Now, if you're past that event, additional industry events, some of these came from the Department of Energy, from their operating experience platform, right? And these were lessons learned from the DOE, Department of Energy, right? And notice this comment in there, right? A strong rule overshadowed a questioning attitude, right? Now, technical inquisitiveness should be maintained when reviewing. This is a critical lift, and you'll see what the discussion was here in a minute. But they were doing a heavy load lift, right, with a crane, right? And what happened was it didn't go according to plan, as you'll see here in just a second. And what they said was a questioning attitude and technical inquisitiveness during work or task performance will help identify weaknesses that may lead to significant events. So here's the discussion. While lowering equipment into this building, the load shifted and these spreader beams providing support under this box that they were lifting contracted these support legs. This caused the load to become unbalanced and the glove box moved from a horizontal level to a 45 to 60 degree angle. Now, previously written instructions for lifts had not been followed verbatim. So the people that were doing the lift were under intense pressure that says, when you lift this thing, you need to make sure you follow the instructions verbatim, right? Now, based on this experience, the workers were expected to follow manufacturer's instructions as written. In this case, the manufacturer's instructions for lifting were developed and used in a controlled indoor environment. Example, for movement of equipment within a shop with a minimal elevation. So they were following these instructions from the manufacturer, but the difference was the actual lift they were doing was from 35 to 40 foot to clear some building concrete walls. The manufacturer may not have understood that the lift was involved at this height with a narrow landing area. Plus they had weather conditions that were influencing this lift. So the manufacturer's lift plan did not show the lifting device positively attached to the load, right? Now, discussions where personnel identified as concerns about challenging the manufacturer's information because it was drummed into them that they had to follow it verbatim because of previously they had some inconsistencies where they may not have followed instructions verbatim, and it really didn't happen well for them. So this time they were like, hey, when you lift it, follow this, but yet the conditions weren't the same, right? So the individuals followed the lift plan to the letter of the law and gave up on the questioning attitude. This is verbatim from the operating experience report. Additionally, there was another operating experience came up that says, hey, and this was the title for it. It was called A Questioning Attitude is a Crucial Component of a Thriving Nuclear Safety Culture, right? And the statement, and again, this is exactly from the report. It says an essential behavior necessary to demonstrate a thriving nuclear safety culture is to have a questioning attitude, right? From the operator in the field identifying an abnormal condition to the engineering and support groups reviewing options for correcting these abnormalities, a critical questioning attitude is required to prevent minor problems from becoming big problems and not allowing past practices to prevent us from recognizing past errors. In the discussion, they said an operator was actually doing his rounds and noticed a mist coming from this tank purge exhaust ventilation stack. Boy, I never seen that before. Boy, I don't know why it's a mist coming from this. The operator notified the first line manager, and after a brief evaluation, the ventilation system was shut down and the steam to a reheater coil was isolated. So evidently they must have had a tube leak, right? Shift manager was then contacted to concur with the actions taken, and they entered a limiting condition for operation for a slow generation tank loss of the ventilation system. The observant nature and questioning attitude of the operator who initially discovered the abnormal condition was critical in preventing a potential release, which could be a potential radioactive release from the ventilation system due to moisture accumulation and potential filter wetting, right? So how do we fix this? Separate facts from assumptions and opinions. Validate your assumptions. Be aware of the critical aspects of the task. Do not assume approved sources are applicable or infallible. I have never seen a perfect piece of engineering, and I'm an engineer. I've written them. I like to think I was perfect. I'm not, right? Do not rationalize away inconsistencies. I've seen procedures at Rev 10 or later, and someone raises the question and says, why are we doing that? And then you go back in history and you find out there is no reason for it. Or maybe there was, and maybe we're not applying it the same, or it was changed, right? And that step was wrong. And here it's been in there all those years, right? Do not follow procedures without critical thinking. You are not meant to be a robot. You got to engage your brain and make sure that you're reading the steps and understanding their intent without just becoming a person who just opens a valve, right? Seek help when faced with uncertainty. In conclusion, when should you have a questioning attitude? Here is a list of things that actually were online sources and training courses that I found at the taproot.com, with the root causes group in there, which is a great resource, right? Here's a list of compiled from online sources. When should you have a questioning attitude? When you feel uncertain, when your gut tells you there is something wrong, when something unanticipated happens, when you're using the human performance tool STAR, stop, think, act, and review, when making important decisions, when you're confused or in doubt, when you find something missing, when someone says, we've always done it this way, right? When you encounter inconsistencies, before doing something important, like a critical procedure step, when plans and procedures don't agree, when plant conditions are different than you expect, when you encounter something new or different, when you hear, I assume, probably, or I think, right? When normal processes fail, don't produce the expected results.